Hello there, I'm Dr. Zwain, and today we're going to learn about gravity and how air resistance affects it. We all know what gravity is. It's the downward force generated by the Earth. Everything is affected by gravity, even things up in the air. However, when you go against gravity, or any force for that matter, you encounter a friction force. A friction force is a force resisting the relative motion or force an object generates. The friction force we'll be discussing is air resistance. Air resistance is a friction force that generates in the opposing direction of a velocity. The most common example is when you go skydiving and open your parachute. As you're falling, both gravity and air resistance affect you. As you fall, the air molecules generate a resisting force slowing down your descent. The air resistance is dependent on a lot of different factors, but the primary factors are an object's speed and its lateral surface area. Objects with a higher speed and a larger surface area will have a higher air resistance, while objects with slower speeds and smaller surface areas will have lower air resistance. The most important aspect of air resistance and what it does to a descending object is force the falling object to reach terminal velocity. An object is going to continue to fall at a constant acceleration of 9.8 meters per second squared until the air resistance force equals the speed of the falling object. This is called terminal velocity, and all it means is an object is no longer accelerating and maintaining a constant velocity that cannot grow higher. So with all the fancy definitions out of the way, let's see what we're talking about. So here I have a 5-kilogram bag of tools and a 5-gram piece of paper, two vastly different amounts of mass. So you probably can't see it, but right now I'm being affected by gravity. Gravity is what's keeping me from floating up towards the sky. However, as long as I'm standing still on the ground, I'm not being affected by air resistance. This is key, because as long as an object is not moving or maintaining a velocity, it's not going to be affected by air resistance. Okay, so it's time to demonstrate air resistance. First, let's drop the bag of tools from a height of 6 feet, or 1.83 meters. Notice how fast the bag dropped. It took about a second for it to land on the ground. Now, let's drop the paper. See how much longer it takes for the paper to reach the ground? This is where things can start to get tricky. Newton's laws of motion tell us that an object will continue to accelerate until both the downward force and the air resistance force equal each other, creating terminal velocity. The reason the bag of tools hits the ground faster than the paper is because the bag is far more massive than the paper. Since the bag is more massive, it weighs more, resulting in a greater downward force of gravity. The bag has to accelerate for a longer period of time before there is sufficient upward air resistance force to balance out the forces. The paper, having a much lower mass, has smaller weight, allowing it to reach terminal velocity a lot faster, making it to appear to fall slower. So how does surface area affect air resistance? Well, when you go skydiving, your body's surface area isn't that large, making it so you don't encounter a lot of air molecules as you fall. The parachute, however, has a much larger surface area, allowing you to hit a lot more air molecules, helping create much more air resistance. That larger surface area helps you achieve terminal velocity a lot faster, which is why you appear to descend slower than if you were just free falling. Everything on Earth encounters some form of air resistance, when it goes up or down. Even when you drive your car or walk down the street, you're encountering air resistance. It's only when you're in the vacuum of space that you won't encounter any air resistance. Well, this has been Dr. Zwain, and I hope you learned a little bit more about air resistance. And remember, just because you can't see it doesn't mean there isn't physics behind it. See you next time.